Hi, I'm Selva Prabhakaran. In this one, let's solve a practice problem based on the binomial distribution. This is something that you should be readily able to relate to in your day-to-day life because we are going to be talking about a e-commerce retailer. We are assuming it imaginary name called EC-Cart. Okay, so EC-Cart is selling a baby food. There's a spelling mistake. Baby food product called Grow Baby. Now, EC-Cart is having multiple sellers on their platform. So there are 3 different sellers who sell the same product called Grow Baby. What EC-Cart also wants to do is they want to ensure fair play amongst all the sellers so that they want to make sure that none of the sellers are actually manipulating the product ratings using fake reviews. If something is off, because all these three sellers A, B and C are selling the same product, right? So overall, if you think about it, all the 3 different sellers should be receiving a similar rating or comparable rating to each other, isn't it? Now, seller A has 75 positive ratings out of 100 ratings. So their average turns out to be 0.75. Seller B has 25 positive out of 40. The average is 0.62, which is nothing but 25 divided by 40. All right. Likewise, seller C has 166 positive ratings out of 250 ratings, whose average turns out to be 0.66. Now, what we want to do is to use the binomial distribution ideas to help EC-Cart detect if any of these 3 different sellers are committing some sort of a fraud or not. Typically, the fraud is going to be around putting fake reviews around their products. Now, in order to use the binomial distribution, we need 3 parameters for each of these tests. We need the K parameter, which is the number of successes. We need the total number of trials. And we also need the probability of success, P here. This is not readily available here. For each of these tests, K is 75 here. For seller A, K is 75, N is 100. But what is P? P typically should be the probability of success that should already be established, right? Now, if you have a situation where you have a lot of different sellers for baby food, something similar to Grow Baby. Okay, Grow Baby might be one type of baby food. You could also have a lot of different baby foods in the platform sold by similar sellers as well. Now, from all those different set of ratings, you could take the average ratings from similar sellers on similar products, very similar products, all right? You could do this, you could compute this average and call that as the expected probability of success, all right? But now in this case, we have to deal with only 3 different rating values, 0.75, 0.62, 0.66, only 3 different values. So what we will do, we will simply take an average of these 3 ratings because we don't have the full data available to us. We're going to approximate P to be the average of these 3 values, and that turns out to be 0.68 approximately. Okay, so we are going to make this assumption and work through solving this problem. So let's use the PMF calculation for each of the 3 different sellers, PMF for binomial distribution. So probability of getting 75 successes out of 100 trials with a probability of success equal to 0.68, we can use the formula KNCK multiplied by P power K 1 minus P power N minus K. So this is the formula, right? We are substituting all of this here for all the 3 different cases. So for seller A, N equal to 100, K equal to 75, we are getting from this directly, right? And P we know, this is the same for all the 3 different sellers. So 0.68 power 75, 0.32 power 25. Okay, by doing this, we get the probability to be this particular value, 0.2829. We do a similar exercise for seller B and C also. Do the substitutions, we get the respective values. We get the 3 different respective values. So what do we conclude from this? The probability of observing this for seller A, right? The probability of observing 75 positive ratings, average probability of success stands at 0.68, right? This is the expected. If average rating is 0.68, average success probability is 0.68, out of 100 trials, I would expect 68 success rate, right? 68 positive reviews out of 100 trials, 100 reviews, right? But we are getting 75 here, which is significantly larger than what we would expect. But is it statistically significant to be declared that this is too abnormal? That's what we are trying to find out, right? We will get to that. But amongst these 3 different probabilities that we have here, the probability of observing this situation is the lowest amongst these 3 cases. these three sellers. So amongst these three sellers, seller A is the suspicious guy. Okay, we will further confirm this using something called the binomial test. So what we are going to do is we are going to do this test. This test is going to consume these three values. In addition to this is also going to give us a p-value. Okay, I will tell you how to interpret this p-value. We will look at the concepts of hypothesis testing and conducting statistical tests and how to read these values and how to interpret them. Those aspects we will cover in detail at a later point in this course. Alright, but right now we will simply look at the p-value and look at the basics of this binomial test and learn how to make a call, how to make a judgment on whether to call this as an extreme absurd observation that is very deviating from the normal behavior and declare or mark this out as a fraud, right? Because unless seller A is doing something very different and legitimately radical to sort of get a very good positive rating from the rest of the sellers of the same product, right? Unless the seller A is able to justify this kind of a huge positive rating, significantly higher positive rating, then this particular seller could be considered as a potential fraud case. So let's see how to do the binomial test. So we are at the documentation for scipy.org. I hope you are able to see this. docs.scipy.org. We are inside scipy.stats.binom test module. And you can see that this particular test takes in three parameters, K, N and P. Okay. So by default, P is set to 0.5. Now for our case, we might want to change this to 0.68. Alright, this is clear. Now every other statistical test, so this is a hypothesis testing, right? So every other statistical test assumes a null hypothesis by default. Okay, so in this case, the null hypothesis is that the probability of success in a Bernoulli experiment. So Bernoulli experiment here in this particular case is a user rating a product as either positive or negative, right? Only two different outcomes. So therefore, this can be considered as a Bernoulli experiment. Okay. And this probability is considered to be 0.5. Now, when we are implementing the test, we will change this to 0.68. Okay, that we will do. Now, after implementing this test is going to give us something called the p-value. Okay, if you are not familiar with what a p-value is, how to interpret it is very simple. If the p-value is lesser than a significance level, we will always assume, we call it as alpha. Typically, this is something that we, by default, assume as 0.05. We don't typically play around with this for most practical cases, right? With alpha, if p-value is lesser than this alpha level, p-value is lesser than 0.05, then we reject the null hypothesis, which we typically write it as H0. So null hypothesis here is the probability of success is P. This is the null hypothesis. And in our case, the probability of success is going to be equal to 0.68. Now, if p-value that we get out of this test, if it is lesser than 0.05, then we reject this null hypothesis. What does that mean? That means we are rejecting the assumption that the probability of success for that particular seller equals to 0.68. So we are rejecting this claim in the first place. And since the actual calculated probability, that is 75 out of 100 reviews, is greater than this particular value, we will conclude that assuming that we are getting a p-value lesser than 0.05. Okay, if this happens, then we will conclude that that particular seller is sort of abnormal. So with this context, let's implement it in Jupyter Notebook as well. Implementation is quite straight. Just import binom test from scipy.stats. We import this, then run it. K equals to 75, N equals to 100, P equal to 0.68. We don't change this, alternate equal to greater. We will deal with this particular concept in detail when we are studying hypothesis testing. Alright, so this is done. We have run the test and the results are stored here. You can see the p-value here itself. Alternately, you can print out the p-value from the result object. That turns out to be 0.0796. So this is close to it is very close to 0.05. But as we decided, so alpha level is 0.05. As we decided, we will reject H0 only if p-value is lesser than 0.05, which is not the case as we are observing here. So we say that there is not enough evidence to reject the null hypothesis. So we are saying this particular seller A is not having a suspicious pattern as we should expect. That the pattern that we are noticing with seller A is not statistically significant to call it as abnormal. I hope that makes sense. If you have more questions, please leave them in the comments and we will discuss further in the comments area.